Question 34. The Earth is an average distance of 1.50 times 10 to the power of 11 meters from the Sun. Calculate the average orbital speed of the Earth around the Sun. So you might not know what formula to use, but this is actually more obvious than you think, where you're just going to be using speed equals distance over time. Since the Earth is an average distance of 1.5 times 10 to the power of 11 meters from the Sun, that would be the radius, and you have to find the circumference. The circumference of a circle equals 2 pi r, which in this case would equal 9.425 times 10 to the power of 11, which equals distance, given that the radius equals to 1.5 times 10 to the power of 11. And since we already know that it takes 365 days to orbit the Sun, so the time is 365 days, but this needs to be converted into seconds, so 365 days in it, there's 24 hours in a day, so we do 24 times 365, 8,760 hours. Multiply that by 60, since there's 60 minutes in an hour. We get 525,600 minutes, and multiply this by 60 again, since there are 60 seconds in a minute. And we get 31,536,000 seconds. So now that we have the distance and the time, we can find the speed. So speed equals 9.425 this can be simplified to 3.2 times 1, 2, 3, 4, 5, 6, 7. So the speed is gonna equal 29,885.8 meters per second. And this can also be rewritten as 3.0 times 10 to the power of 1, 2, 3, 4 meters per second. So B. Determine the centripetal acceleration of the Earth towards the Sun. Centripetal acceleration equals velocity squared over radius. So we already know the velocity and we know the radius, so this can be rewritten as 3.0 times 10 to the power of 4 squared over 1.50 times 10 to the power of 11 meters per second, and this is gonna be meters. And after plugging this into the calculator, you get 5.9 times 10 to the power of -3 meters per second squared as the acceleration. Now finally, for the value of the mass of the sun, we can use the equation orbital speed equals the square root of g m over r, where m is the mass of the sun. So first we have to square both sides. V squared equals gm over r, and then we multiply both sides by r over g, so we get v squared r over g equals the mass of the sun. We know g is a constant of 6.667 times 10 to the power of negative 11, and we already know what the velocity is and what the radius is, so we rewrite the equation as 0 times 10 to the power of 4 squared times the radius of 1.50 times 10 to the power of 11 all over, sorry, wait, let me fix that, over 6.667 times 10 to the power of negative 11, and we get 2 times 10 to the power of 30 kg. So the mass of the sun is going to be 30 kilograms.